With so much activity in space already, and more missions being announced by governments and the private sector right across the world, space junk and what to do about it is already a significant issue that is only going to become a much bigger one. To talk about this, David BUTTSWORTH is Professor of Thermofluids Engineering at the University of Southern Queensland in Toowoomba, and he joins us now. Welcome to the show, David. Let's start with the different kinds of space junk out there and exactly how are they created?
Yes, very good. Wide variety of space junk, ranging from spent rocket stages through to satellites that are no longer functioning, or satellites that are reaching the end of their life. So big and large pieces, as well components that have been already hit by other components, other pieces of space junk, creating tiny pieces of junk, as well as simply flecks of paint and other much smaller particles that could also be regarded as space junk.
It's mind-boggling and a bit scary. Does the pace of new activity in space coming from so many sectors that I mentioned concern you in regards to the increasing amount of debris that will be in orbit?
Yeah, certainly, and yes, I'm not an isolated person in having concerns about these things. It really is an international problem, and obviously looking for ways to improve safety up there, which means improving safety on the ground as well. These are critical matters that need to be addressed.
And we all hear about spacecraft and satellites breaking up upon re-entering the Earth's atmosphere, but it's surprising to discover that we don't actually know about what happens with it.
Yeah, that's right. Obviously there's a certain degree of knowledge about what happens, but when you consider the wide range of different sizes and shapes of objects, as well as what they're made of, some things are better suited to re-entering. Obviously, a space capsule, you want that to re-enter without any damage to the contents on the inside. But other components, you'd ideally like them to burn up or vaporize in the atmosphere, but that's not always the case.
Well, tell us about the research work you and your colleagues are working on at the University of Southern Queensland and how it has the potential to make a big difference.
Yeah, no, thank you for the opportunity. We're looking at how different objects, when they are re-entering the atmosphere, how they separate from each other, and how the aerodynamic forces cause them to separate, so that if they do make it through the atmosphere, we can have a better analysis or a better modelling, a better prediction of where these components are going to land on the Earth. Ideally, you'd like these objects to land a long way away from people and property, but that's not necessarily the case always. There's many examples of space junk making it through the atmosphere and coming frighteningly close to injuring people and certainly damaging property. So being able to better model how these things transit through the atmosphere and what the danger zone is underneath their path. This is what our research is about.
So am I right in thinking that part of the plan is to identify somewhere on Earth as a designated rubbish dump, I guess, for space junk?
Well, there already is a designated zone for disposing of your space junk. There's two large bodies of water, one to the east of Australia and one to the west of Australia. There's areas in both of the Indian Ocean and the South Pacific Ocean that are really a long way away from land, but it's not always the case that operators successfully land their material in these zones. So I suppose we're talking more about a situation, for whatever reason, it's not possible to accurately and confidently target those zones, in which case the junk may land somewhere where you don't want it to, and being able to identify the hazard zones in such a circumstance, this is the direction we're coming from.
So the outcome of your work essentially is, can you get a safety plan for humans and all life on Earth when it comes to space junk?
That's the big picture thinking, indeed, yes. So we're tackling the problem from both a theoretical and a experimental point of view. So the experimental approach that we're taking is one in which we do experiments in our hypersonic wind tunnel at the University of Southern Queensland. And we're able to simulate aspects of the re-entry process and simulate how objects that are flying in close proximity, how these objects separate as they're travelling at hypersonic speeds. And we're coupling that with theoretical models of the process in order to tune or calibrate our theoretical models. And in that manner, we're able to obtain a better picture of what the hazard zone is going to be under a wide range of different objects that we might consider that are going to re-enter the atmosphere in the near future.
Given the real dangers for us that space debris poses, should a global treaty be put in place to manage what can be jettisoned in space and how end-of-life satellites should be dealt with?
Yeah, look, absolutely. And, there's already conventions around these things. Operators of satellites and launch system, launch providers are supposed to have in place plans to safely deorbit their objects at end of life. It's good that these plans are in place. Unfortunately, not everybody adheres to these treaties, as it were, and as well, even though the intention might be to adhere to these treaties, it's sometimes the case that things go wrong, and making it impossible to have as good a control of your spacecraft as you would like. So, yes, you're absolutely right. As good corporate citizens using space, everybody should be adhering to the convention that what goes up must come down and must come down safely. But this is not always the case. So being able to manage situations like that is very important.
I mean, even if countries are working together, will we ever get to the point where the dangers posed by space junk are mostly mitigated, or will there always be that element of unpredictability with this?
Yeah, look, I think it's always going to be the case that this is an important endeavour. Ideally, we'd like to get rid of all of the space junk and have complete control. Then that's not always the case. And as well, it's not entirely science fiction to be considering a meteor, some sort of extraterrestrial piece of material that's heading towards the Earth, and being able to identify how such an object is likely to break up, and what is the hazard zone underneath such an object. You don't want to cause panic, but you want to manage these things safely. And there's various possibilities to that. But if you've come to the conclusion that an impact on the Earth is inevitable, you want to be confident in the management of that scenario as well.
Yeah, no need to panic, but definitely we're looking at the skies in a different way after this conversation. David Buttsworth, Professor of Thermofluids Engineering at the University of Southern Queensland in Toowoomba, Australia. Thank you so much for joining us.
My pleasure. Thank you.